What is routing in networking? Routing in a network is the process through which data packets are directed from a source to a destination within a network. This task is performed by devices called routers. Routers use routing tables which contain information about available routes in the network to select the best path for transmitting data packets. Router must continuously update their routing table to ensure the selection of the best route. They must choose the most optimal path for sending packet from the source to the destination, and after selecting the path, routers forward the packet to the next node in the path until the packet reaches its final destination. But how? You have two options for this. Either use static routing or dynamic routing. In static routing, everything is up to the network admin. It means the admin select the best path, and if that path gets interrupted, the connection will remain down until the admin resolves it or introduces a new path. However, dynamic routing works differently. In this type of routing, routers automatically discover and update routes using routing protocols. This method is suitable for large and complex networks. At first glance, one might think dynamic routing is always the best choice, but in reality it has its own specific use case, and in most projects we use both simultaneously, so it's better to familiarize yourself with all these methods and learn them well. In this scenario, we're going to learn about static routing and use it to connect to the internet through the router. Let's get started. Just be aware that this video is part of the free course Build Your Own Secure Castle course. So if you encounter any issue during the video, be sure to check the playlist link above, and if your problem persists, please share it in the comments. I'd be happy to answer your question. Alright, let's enter our Fortigate Firewall. We navigate to the network section and go into static routes to create a new static route. We have several options: destination, gateway address, and interface. What are these used for? Let's assume we have a firewall with built-in routing capabilities, similar to the previous scenario. Since we're discussing routing in this season, are represented with R1. We also have a switch and two PCs with the subnet 192.168.2.0/24. Additionally, we have another router, R2, connected to a server with the subnet 2.186.22.0/24 via port 2. Now, I connect these two routers to each other via port 1 with the subnet 192.168.122.0/24. We want to set up connectivity so that PC1 and PC2 can access the server with the IP address 2.186.22.10/24. Now, assuming we're on router 1, I instruct PC1 and PC2 that if they want to reach the server, they should go toward router 2. First, let's look for a common interface between router 1 and router 2. It's straightforward. The subnet 192.168.122.0/24 is our common interface. In the destination field, I write the server's IP address. For the gateway address, I put router R2's IP address, which is 192.168.122.1. Remember not to put your own IP address here. I mean 177. So far, so good. In the interface section, we need to select the outgoing port toward router R2, which is port 1. Now, if we want the server to also have access to the PCs, we need to perform the same configuration on router 2. In destinations, I write 192.168.2.0/24. And for the gateway address, I put the IP address 192.168.122.177. With this setup, the server and the PCs have connectivity. Now, let's talk about administrative distance. In this scenario, if we had another route to reach server 2, the router would choose the route with the lower administrative distance. Essentially, administrative distance determines which route among different routing protocols is more reliable. Administrative distance is set to a default value of 10, but if you know a closer and more reliable route, you can lower the administrative distance for that route. In that case, the router prioritizes that route. Great, in this tutorial we're going to connect Fortigate to the internet. Imagine we have multiple routers, each connected to a different server, and all these routers are interconnected via different routing protocols. Wait, it's almost done. Oh, how interesting it looked like a star. I'll name them Internet. Whenever we talk about the Internet, we represent it with 0.0.0.0/0. In the Internet, you can write a static route for each IP address. So, what can we do? It's simple. I go to router 1, and in the destination field, I write 0.0.0.0/0, and in the gateway address field, just like before, I write 192.168.122.0/24. 1. And I'll choose port 1 as the interface. When you receive internet from an internet service provider, you get the subnet and gateway via DHCP or manually on your router's interface. Before we start the configuration, let's also check the Advanced Options section. Here, we become familiar with a feature called priority. Priority determines which route has a higher priority. Similar to administrative distance, the route with a lower priority is selected. In general, administrative distance is used to choose routes between different routing protocols, while priority is used to determine internal routes and manage traffic on a specific device. As I mentioned in previous season, the Fortigate Firewall user interface is very user-friendly. For example, you can select various pre-configured services in the Fortigate Firewall and change their gateway and priority. Now, let's start configuring. To begin, I add a NAT to our scenario and connect it to GNS3. I'll name it Internet 1 and connect it to port 1 of the firewall, just like before. Okay. I place the scenario and firewall side by side. As before, I put the scenario and the firewall together. Now, I'll enter port 1 of my firewall and name it Internet. Based on your needs, by changing the rule, the firewall enable or disable certain related feature for you will become more familiar with this later on. Since this interface is intended to be the internet-facing one, I change the rule to WAN. Depending on the type of internet connection you have from your internet service provider, you can obtain or create the IP address in the address section, either manually or via DHCP. I choose DHCP. From the Retrieve Default Gateway from Server section, I can control whether to obtain the gateway address via DHCP or not. I can also do the same control on the DNS address by enabling or disabling override internal DNS. For simplicity, I keep this option enabled. Since this port is connected to the internet, I disable all access. And done. If you remember, from the first video, we activate DHCP under type for NAT in VMware Workstation. If you haven't watched this video, I recommend checking it out from the link above to avoid issues during scenario setup. Now, I'm expecting that after connecting the NAT, the firewall's port 1 will receive its IP address. This IP address can be different on each computer. Great, we easily obtained our own IP address. Along with that, the gateway and DNS address were also obtained. Now, I enter static routes and start writing the route just like in the scenario I draw at the beginning of the video. Remember the scenario? Alright, I set the destination to 0.0.0.0/0 and the gateway address to 192.168.122.1 and the interface is automatically recognized. Remember, we enable retrieve default gateway from server. It comes in handy here. We can select the automatic gateway retrieval option and let it replace interface and gateway distance. Choose interface and let it retrieve the gateway for us. And that's it. Let's test it. I open the CLI and ping 4.2.2.4. Excellent. Let's test it on PC 1 and PC 2. Oh no, why don't they have internet access? What do you think the reason is for not having internet access? If you remember from the third station video, we have something in firewall policy called implicit deny. It means that for every function in the firewall, we must create its access. Secondly, we need to use a network technology called Network Address Translation or NAT. I create a separate video to explain how NAT works so you can become more familiar with this network technology. Now, let's continue. I'll create a new policy. I'll name it LN Internet 1. The incoming interface is the interface to which we want to grant internet access. And the outgoing interface is the interface toward the internet. We can restrict source, destination, and service, as we did in the second session, but in this scenario, I set them all to all. I choose accept as the action. Okay, I can easily enable NAT from here and perform various configurations with it. Since this video is specifically for routing, I won't explain it here, but I definitely create a separate video for it. As usual, I check the log option. That's it. This is just one of the instructional videos from Build Your Own Secure Cassette series. If you found this tutorial helpful so far, please like the video. If you're interested in network and network security topics, I recommend subscribing to my channel and hitting the notification bell to stay up to date on the continuation of the tutorial series. Now, let's test it. I start with PC1. Excellent. Now, PC2. I think it didn't get an IP address. I run the DHCP command once. Alright, let's test it again. And we're done. If you have any question or comments, I'll be happy to hear from you under this video so you can secure our network together.